Are there any big questions before we dive into anything? We all got our plain books filled out correctly. I will get the homework up on that board over there. Sorry, I ran out of time this morning. I was doing some scanning. All right, I want to show you guys something really cool. That's a great resource that you will have to use your parents to get to. So, an email goes out to your parents every single week with an update on what's going on at Phoenix. In that email, there's little blurbs from whoever decides to put a blurb in. This week, and I don't think the email's gone out yet, your parents are going to receive that email, and there's going to be a blurb that says, from Mr. Hudson. And in that blurb, there's a link to a Google Drive folder. And in that Google Drive folder are solved homework assignments. Right now, up through 1 through 7, I'm going to keep solving, and there will be more. But so, your last 3 homeworks that we turned last week, I believe, were 115. There's my version of it done. 121, I think I forgot to finish it, so that might actually be my bad. And then 122. You love your boxes, don't you? I'm very organized when I do my homework. So tonight's homework, 1, 2, 3. Let's say you have some issues with it, and you need some help, you need to look stuff up. Notice my headers are a little weak here. I need to get better. I need to make sure I put number to number. Here's tonight's homework. 1, 2, 3. Done for you. Tomorrow's homework. Notice how much work I have in my homework, though. So take a moment and actually look at this. I show my work. I show my thinking. I even show when I'm going from a fraction to a fraction that I multiply by 2, or I multiply by 10, or I divide by 5. I show my thinking. Okay, this is what I'm expecting out of you guys. And as we move forward, your homework checks will get a bit more detailed and a bit more detailed. Right now, we're really just checking, did you do your homework and did you turn it in? But as we move forward, I'm going to expect your homework to look like this. I've got some people in here right now that are really resisting showing their work. That's not going to work out for you long term. And when it comes to our mastery, the more work you've shown on your practice, the more things will make sense in your brain. So then rewriting fractions homework, not a ton of work, but enough shown. Rewriting fractions into percents. We'll start to use the giant 1. And then I make little notes in my homework to help you guys out. So if we multiply left to right, then we're dividing right to left. Like if I go the opposite direction, I do the opposite order. So I'm showing kind of working both directions here.
So you're giving us the answers to homework?
Yes.
But he's trusting us.
Why? So why doesn't that make sense to you? This is a great conversation to have.
No. I'm not saying I'm the one who's talking about homework. I'm just saying some kids love
So, hey, I need you guys in here. We're having a conversation, and we're all part of this.
So, some kids, not me, obviously, I like when I do my work.
So let's play this out, though. Let's say Aiden's really busy. We got cross country or whatever else. Aiden, for this week, does not do his own homework. Instead, he convinces his mom to let him have the Google link. He uses mom's computer or whatever. Mom gets him into the Google link. And he just goes and he looks at all the done homeworks and copies them. Do you think he's going to learn the material?
No, exactly. People who copy it don't learn.
Okay.
He's going to copy it down, and then whenever it comes to taking the test, he's not going to be able to, he's going to get confused and not understand what the question is.
What's one of the biggest foundations of our school? Mastery learning. What does that actually mean? Joey? Yeah, that you actually have to understand it. So when it comes to an assessment, guys, I normally can safely tell you guys the practice is harder than the assessment. I try to look at what we've done through practice that week, or the couple weeks, and make my assessments close to that, but not quite that challenging. But if you haven't done the practices, you've probably got no shot. So, yes, I'm giving you guys all the answers, but under the caveat of, I'm going to know if you just go on there and copy something. What it should really be used for is help if you're stuck or checking your answers. If you don't know if you did a problem right, if you're trying to figure out what the correct way to do it was, you can use this to check your answers that way. Today we are in 1, 2, 3, and we are modifying sample space. So you don't need to give me your textbook right now. We can take care of that later. This, you need to check that you have good headers and that it's in order, but then you can just staple it and turn it in whenever you're ready. So even like you can wait till the end of class if you want, or do it right now if you want to know how fast. So you'll notice something different from what the book has, from what your bag has, which there are two groups that have not followed directions yet. Let's just figure this out now. What groups are struggling? We didn't get our probability bag. Who else? Got it. So guys, one of the biggest things that we got to get in the habit of doing, and some of you are really, really good at this, and some of you are still developing, when you walk into the class and this is on the screen, you need to look at every part of it. Now I get it, like this hardly ever changes. Really, barely ever. But down here, this will change for what you have out. The only reason I didn't put the bag of blocks here is because I didn't want everybody thinking you needed your own bag of blocks. And math book, we've talked about that you need like 1 or 2 per team. Each of you doesn't have to have your own, you can share. Because this stuff under here is critical. This is your homework in the box. That's why it says plan book. Very easy. Write that in your plan book. That is your assignment. So this exactly should be in your plan book. And then you do whatever this stuff says. Okay? So we just need to get in that habit as we move forward.
So are we going to finish our books this Friday?
I've been going through kind of fixing ones that I can find. If your book cover has some issues, come see me like AL or extensions or whatever. We can fix it. We don't need to do that together as a whole class. I think we're all right on that. I'm going to go ahead and read to have us dive in. So please either look at a book at your group or up at the screen. What should everybody have out right now? Because we're 3 weeks into school. I should not need to keep reminding us. Ava, what should we all have out right now? Yeah, math binder. That's up to you if you keep your binder out or if you just take a piece of paper out of it. But everybody should have out paper, pencil, potentially a math book to look at or one shared with your group. Your name tent would be awesome. But especially I see some boys around here that are sitting with like empty desks. Just like waiting for a handwritten invitation for somebody to ask you to join us. All right. If you want to have the best chances of getting a red gumball from a gumball machine, is it better if the machine is full of gumballs or half empty? How do those chances of getting an ace and a deck of playing cards change if you have 3 or 4 decks all shuffled together? So in this lesson, we're going to think about what is called sample space. So the first thing we're going to do is write down in our notes what sample space means. I'm going to flip my screens. Let's head our notes for today. What should be in the header?
How can I change the chances?
Close. Yeah, I don't want to write that much. 1.2.3. So I want you to add this on the top of your paper. And then I'm just going to write modifying sample space. Because that's the title of the lesson under that. So the big text of how can I change the chance, how can I change the chances? That's like their question to get you hooked in. But what we're learning about is modifying sample space. Now to understand what that means, we need to understand what sample space is. Can you have your paper? Oh, we got it over there. What is sample space? It says it up there. Appropriate 7th grade classroom behavior. Thank you very much. Ivan, what's sample space?
The collection of all possible
The collection of all possible outcomes
outcomes of an event.
of an event. That's even too wordy. I'm trying to make your life easier, so please write down sample space. No abbreviations. There's really no way to abbreviate that very well. We're going to make it real easy. 3 words. All. This shouldn't be capital. All possible outcomes. That's it. In your bag right now, you have a certain sample space. I want you guys to try to list what are all possible outcomes for your bag? So what is our sample space? Verify it with your team. We do not need to talk about the probability of anything yet. We just want to talk about what are the possible outcomes.
Oh, I thought you said there was 75 and 1 dash 75.
Yeah, sorry, problem 75. I don't normally write the 1 dash because I already know I'm in chapter 1. I'll ask the easy question first. How many different outcomes are possible? Joey? Joey, how many possible outcomes? 4! A lot of people are thinking every single block. There are only 4 possible outcomes. What are they? Yellow. Green, it doesn't matter how many of them we have. Blue. And red. There's only 4. I'm throwing things at Casey. There's only 4 things that can happen. Now, I have a lot more than 4 blocks in my bag, but I only have 4 different types of blocks. Right? So these sample space just lists out what things can happen. Not how many, not the probability. Sample space is just what can happen. Does that make sense? Do you have any questions on sample space? Yeah. Okay, yeah. All right.
So like even if you like mix all the colors, like say you red, blue, green, yellow, red, blue.
Yeah.
It would only still be 4 colors.
Right, exactly. Unless we put different colors in, right? Swap some of the blocks out. So, as we go today, here's what we're thinking about. How has the whole or total changed? How has the portion that we're looking at or that we're interested in, this is like what we're trying for, how's that changed? And has the event actually become more or less likely? So now we need to modify our bag. You guys got to take some of your blocks out. We want to set your bag up with this. 1 yellow, 2 red, 4 green, and 5 blues. Make that happen. You have too many right now. Modify your bag. I'm going to come and get your cards so you can hand me your cards as I come around. Thank you very much. I'm not 100% sure who we're missing today, ladies, but they'll be with you. I forget who is absent today. Thank you very much. Thank you. Then when you're ready, I should see people pencils in hand ready to move on. Now, I need a reminder of how we write probability, but then I'm going to let your group just work together. Jalen, how do I write, like, if I'm going to... P parentheses. So... Apparently that's angry too. Where's my other pen? So we want to write in our notes, you should have labeled 75. If you haven't, I don't know why Smart Ink isn't working today. I'm going to switch my screens because apparently something's wrong. Guys, we're still having a minor problem, and I get it. Today's kind of like a Monday. But we have a lot of people that are just doing their own thing. You're just having your own conversation. You're like thinking about whatever you're thinking about. I need you guys to join me, right? I get you for 45 minutes a day, and I don't even get that long because with Creative Start, we pretty much, the first 5 minutes is like gone. So I really need you to be with me when we're in this space, okay? So these side conversations, if your brain's floating elsewhere, get with us. So you should have 75 labeled on your paper. Then I want you guys as your groups to go through, and you do not have to color code, but I'm going to be all particular. P, parentheses, what you're looking for, figure out that fraction. Then move on to green. P, parentheses, green. Figure that out with your group. with the bags you guys just set up. P parentheses blue and P parentheses orange. I'm going to give you probably like 2 minutes to do that. I think that's plenty of time.
There's no yellow. You mean yellow?
I'm not crazy. This is on purpose. I did not set your bags up wrong. This is on purpose.
What? Is it like yellow and red mix?
Nah. Orange. What? Like, yeah, orange. We're talking about orange. We're red or talk with your group. So what's the probability of it? So let me just say it. Well, never mind. I'll say it in a minute. When you have all 4 of these, one person in your group, give me a thumbs up so I know we're ready to move on. Whoever wants to keep a thumbs up. Sky got you. Ava got you guys. So you can put it back down. All right, now we're using cards. By the way, I'm sorry, this is what I was going to say. That moment of like, oh, that's my favorite moment as a teacher. When you got like, because that is the breaking point of I didn't get it, and now I'm starting to get it. And that's why I teach. Mr. Pearson, if I ask you the probability of red, how do you know what it is?
Because you said you one red, 2 green, 3 blue, and 5 orange.
Okay.
So it would be 1.
Over.
2.
How do I know it?
1 over 5.
1 over 5?
It says 2 red.
Yeah. 1 yellow, 2 red, 4 green, 5 blue. So not 1 red. We actually have
2 red. I have 2 red.
You're good. Okay, so we actually have 2.
Where is this? Whoa, what the heck?
Bless you. Hey, people, especially that were on this side of like talking this morning about like judging people and how we talk with each other and everything else. How do I know what goes on the bottom? The bottom has to be your total. So how many? Yeah, I have 12 total, right? 5 plus 4 plus 2 plus 1. Right, that is 12. I'm not crazy. Yes. So then, Isaac. Now everybody moved right as I started to learn your names. Isaac. Probably green.
My name is Taylor. 4 out of 12.
I wasn't looking at you. Neil, I got your name pretty well. 4 out of 12. So Isaac says 4 out of 12. Because there are 4 green and still 12 total. Greta, what about probability of blue? 5 over 12, right? We got 5 blue and 12 total. Uh-oh. Kevin. What's the probability of getting an orange? Okay. Hold on. Hey, again, side conversations. Guys, I know we're still in the first month of school, but we're taking a long time to figure out like school behavior again. No, it's still summer outside, but sorry, we're back in school. So Kevin, why was it hard? Why did it confuse you? So if we know that probability is how many of what I'm looking at or looking for over total, what should be in the numerator here? 0. I don't want it to be blue though, because I'm particular. It's not yellow, it's not red, it's not a combination of the two, it's orange.
It's not a color.
There are none. Over what? Still 12. There's still a total of 12. Alright, so hold on. I have a question. I need you to ponder it before you do anything. So I want you to think about it. So we're going to do this. Once I ask this question, we're going to say you just silent think to yourself for 15 seconds. I don't think you do it too long. Then talk with your group for 45 seconds. If we put all of the blocks back in the bag all together, will that change our probability? Nobody talk. 15 seconds. If we put everything back in the bag, will that change the probability? Talk with your group. What do you think? And time. Ethan. What type of probability did we just do? Was this experimental or was this theoretical? What's the difference? We need that reminder probably first. So here, let's try this. Brendan, what is the difference between experimental probability and theoretical probability? Do you remember? You guys can always pass all good. Ava, what's the difference between experimental and theoretical?
Oh, yeah, we did this on my homework. Theoretical, isn't that like, yeah, I'm not even going to try to pass.
So guys, this was on your homework from last week. I think actually multiple times now. There was a whole question with like 6 different situations where you had to determine theoretical or experimental. Now, let's be honest with ourselves. Who didn't do that question to the level that you should have? Like, who's not sure right now what theoretical versus experimental is? Let's just be honest. It's okay. If you gave your homework the respect it deserved of like, this is worthwhile, I should care about this, you'd know what's going on right now. Can anyone tell me what's the difference between theoretical and experimental?
Okay.
Yeah, Riley?
So experimental is something that you can prove within
Keep going.
experiment, and theoretical is something that you're just saying
You're really
you have no
close.
proof of it.
Experimental is not that we can prove it, it's that we did it. Give me your eyes up here, because we talked about this last week and apparently it didn't stick. Experiments get done. They have to be like, somebody has to do something, right? You can't walk into science class, Mr. Cabillas is like, we're going to do an experiment today, and just sit down and do nothing. Like, that wouldn't make any sense. Experiments are done. Something has to happen. Did we actually pull blocks out of the bag and test this? No, we looked at it. Right? We said, oh, 1 yellow, 2, like, we looked, this is theoretical. So you should probably make that note. We didn't do anything. Now, I guess I should be careful with how I ask that question. I had you guys modify the bag right when you sat down, only because I didn't want to give you 2 different bags. But then once we started talking about probability, we didn't actually pull blocks out of the bag to test the probability. We just looked at it. We said, how many greens, how many blues, how many oranges? We didn't do anything. We just observed it. Theoretical is from observation only. Okay, we did not actually test it. Experimental probability is we actually did it and we found out this information. Yeah.
Okay, I don't understand everything,
Okay.
but how do you do it with a line? All teachers do that.
It's practice.
I can do that.
Yeah.
I'll teach you.
So we shouldn't really even spend. So really, vertical or horizontal is going to be easier for you. So I started by doing this, and then eventually I was able to turn it and make it sideways. But you just have to get in the like nice fluid squiggly motion. And to be honest with you, Jalen, it's easier for me to write up on the vertical surface than it is for me to write sitting like at a desk or something. Just 'cause I'm so used to it now. All right. So, still back at the original bag that you guys set up when you walked in. Hey, back with me, please. That original bag, we now said, sorry, now to put the bag that you guys helped me with. This is our probability, right? In theory, this is our probability. So, I want you as a team to think about this. If we were to do it, right? If we were to do the experiment, if we were to actually select one block, I guess I can zoom in on this. And when we do these experiments, we're going to assume that we put it back. So that's why it says replacing the block you drew each time. So I can't take a block out of the bag and then leave it out of the leave it out of the bag and do it again. Like, I've changed things. So if I take a block out, I got to put it back in, shake them up, and like try again. So if, now we're not actually going to do this, but if we did this 12 times, how many blue blocks would you expect to draw? Talk with your group. Come up with, now this is 76 on your notes. Label 76. And then write out whatever you think. Like, and it doesn't have to be super long. You can just say, like, I think, 18 blue blocks, which is obviously not right. I think blank blue. He got himself there, he can probably get himself back. Brody, what do you guys think? If we were going to do this 12 times, we carry out the experiment, what's your prediction? You're thinking 5 times out of the 12. Why? I like your thought of 5. I agree with it.
Because there's 5 in there, and you have at least 1 in 11 chance. 5 out of 11 chance.
Based on theory, based on what we see, if there are 12 of whatever, our draws or trials or whatever you call it, we expect 5 of them to be blue. This is what we expect. Would this for sure happen? Not necessarily. We might get 6. We might get 2 or 3. But this is what we predict. So take this question and extend it further. If we did 24 draws. So now I'm going to do like a little squiggly. Whoever saw that, that was a moment that cannot be replicated. Out of 24 draws. Now we'll do this on class answer. What do we think? If we double the amount of draws that we make, what happens to the amount of blue? It's probably going to become 10. 10 blue would be our prediction. Because if we get 5 out of 12...
This is still 76, right?
Yes.
Oh wow, that draws is a real weird word. I just wrote draws in it.
Or you could do trials or experiments, but draws is one of the shortest words that we could put there.
I just wrote it out really weird. I like D-O, and then there were like 3 lines of a W, and it's just trials is better than draws. I'm really tired.
So, put all your blocks back in the bag.
I already did that.
If you haven't done it, put all your blocks back in the bag. So this is going to be 77. So please label this as 77. Now, I'm not even going to scroll my textbook because I don't care what they're doing. I want you with your group, I'll give you a couple minutes to do this, to list all of the probabilities that we have and try to convert to a decimal and or to a percentage. So if you have time, we should have all 4 options. So like first one that we can think about because we were just talking about it is blue. We should have the fraction, then potentially another fraction, and then hopefully a decimal, and then hopefully a percentage. Now you could just do all of your fractions first and then go back to do conversions. But if your group has time, that's what we're shooting to do. And the reason I have the second fraction here is to help me turn into a decimal if it can. So do that for all 4 colors. Go ahead, I'll give you at least 2 minutes, probably 3 minutes.
It smells.
Hey guys, I hear some off-topic conversations.
So 0, it would be, what would it be for,
Okay. So first guys,
Maybe if we weren't talking about the book smelling like dog food, we'd be more aware of what's going on. No, because we're off topic, and you as a seventh grader need to be able to control what you do and what you think about. Right now, I'm going to repeat this one more time, I'm frustrated that I have to do this. What you're doing as a group is determining the probabilities, now that you put all the blocks back in the bag, of each color, then try to convert it to a decimal, convert it to a percentage, if you're able to. So make sure you write P of, so for probability, you got to write P parentheses. So can you see where you're at? Okay. So do I need to be right over top of you guys for us to accomplish anything? No, so I think Casey's trying as hard as possible to just do things. So Casey. So where's everything already?
oh, not blue. No, I'm doing this.
Playing with those blocks is not that fun. Yeah, you got to do it later right now. So then you're bad. You're one too many red. I don't know why. Is anybody missing a red? I don't know why I just opened it up with an extra one. You should have even numbers. Sorry, you should have 24 total blocks. If you don't, that's an issue. So if we would have said that it's out of 24. All of my fractions can start out of 24.
Oh, that's not what I did.
Where's the other ones? We're not just doing
I
blue.
don't
We're
know.
doing every color that we have.
So I'm going to put plus 12.
So why are you dropping back down to 12? I'm just curious, why are we making this choice right here to change that to 12? So it doesn't equal. Sure, split it in half, but where are you trying to go in the long run? Like, what's your goal? Because to turn it into a decimal, we either want the bottom to be 10 or 100 or 1,000. All right, bring it back together because I'm running out of time, regretfully. Nora, can you tell me our probability of blue exactly how it sits in the bag as it is? 10, sorry, did you say 10/24? So then, and this is a big jump, so if you don't know, it's totally fine. Do you know what other fraction could be really helpful for trying to approximate our probability decimal or percent-wise? Do you want a second or do you want to pass? So I get it that you're more like of a thing right now, but I'm going to call him Aviva because she's just nicely raising her hand. Aviva. It's her. Jalen. I'm all distracted by my peripheral over here. I got wacky waving inflatable arm flailing tube man in my.
That's 12.
No?
No?
That's the fraction we had already, that 5/12. So Jalen, now I'm not saying you're wrong, but Jalen says I can do this. Is that true? Yeah, right? Because if I cut this in half and I cut this in half, so wait, has our probability changed?
No, it's just
No.
times 2.
It's just, well, is the probability times 2?
No. Well, yes. I don't know. Yes.
So, kind of. Now, the probability, give me your eyes. I only got like 3 minutes left, so I need to wrap this up. We gotta like put a bow on this. The probability has not changed because we doubled everything. We doubled our blue, which is our numerator, and we doubled our entire everything, which is our denominator. So then when I cut them in half again, they're exactly the same. So I don't think we're gonna have time to do the last parts of this that I want to do, but like, what's the red probability here now? 4 out of 24, which can reduce down to exactly what we had before. What's green probability? 8 out of 24, which can reduce down to exactly what we had before. And we didn't talk about yellow last time. What is our probability of yellow now? 2 24ths. So last time with the smaller bag, what was it? 1/12. Now, I find it very interesting how you all think you know when class is over. We don't have bells, so please get used to the fact that we're not done until the teacher says, like, okay, we're done, like, pack up, whatever. If we were to extend this, so I don't care if you write this down, but I need your attention here, not on trying to pack your stuff up. If we were to extend this for what I was trying to do, because this is gonna be on your homework, I forget if it's tonight or tomorrow, or I get confused on what assignment's happening when, I would like this to become a denominator of 10, or 100, or 1,000, or some multiple of 10 that is just 1 and some zeros. Is there a close way to make this happen? Aiden?
There is, because you could do,
What if I think about this being like 25?
okay.
What could I multiply by?
You could multiply by 4.
I could do times 4. So if we wanted to approximate, now this won't be perfect, but it'll be close and then we don't need a calculator, we can do times 4. This would become 40.40, which then becomes 40%. Biggest thing to understand is we're trying to go to decimal or percent, we need a denominator of 10 or 100 or something like that. We'll pick this up here tomorrow. Sorry, I don't really have time for more questions or anything. I gotta get you guys out of here. Have a wonderful day. Jalen, I'm sorry. Labiba's card was the next one on the deck. So I was looking at her card and I decided to follow her. Yeah, I was trying not to look over there, but it was very difficult to not look over there. Oh, I need you to put all your blocks back in your bags and just leave them either in the binder for your table group or just on it.